So to find out what is an even function, we do a simple test, basically. Well, this is f of x, right? So you can do a f of negative x. What do we do in this case? If it's f of negative x, again, you do not give any special treatment. You do exactly what you would do if it's just f of 2. You replace all the x's with whatever that's placed inside the parentheses at the moment. Okay. And then we say, oh, what is negative x to the 4th power? X to the 4th. What is negative x squared? X squared. And then plus 5 remains unchanged. So then you look at this notation right here. Okay. And then you compare with this notation right here. What do you see? They're the same. So that means f of negative x is equal to f of x. And that means our conclusion is this is an even function. So sometimes you might get lucky, okay? But you would never, ever judge a function being even or odd simply by looking at their exponents. That it's never a reliable or an accurate way of finding a function being even or odd. But that's what I did, and I was stupid, so don't be like me. Okay, so right now, last year I also saw people doing this. Okay, this works. Okay, I want to show this with you here. So somebody actually kind of use the same idea, but not with x, but using a number. So this student would do this. Okay, he would do I forgot he or she, but the student did this. So first he did f of 1, and then he would actually compute what that is equal to, and that's equal to 3. Okay, and then the student will put in f of negative 1 and then compute what f of negative 1 is equal to. Okay, if you're pretty good with math, you realize that the negative, it's being raised to an even number power. So, hey, the negative, it's gone. So you got exactly the same thing. And the fact that these two are the same numbers would also prove that, hey, it's an even function. So now, of course, I will prefer this method, okay? Because that is really the most original idea. But if you say, I somehow forgot, but I want to give a shot, if you do this, okay, I will still take it. Okay, that's a good try. That's a good thought process, okay? Understanding that if you have a reflected function over the y-axis, then they should share the same y value. Okay. All right. So for part B, same deal. We would do f of negative x. Okay. Same deal. F of negative x, and negative x cubed would remain negative. Okay. All right, like this. Oh, sorry, forgot the x here. All right, now, so you take a look at this notation. Okay, so this notation, negative x cubed minus 4x minus 7. And this one right here. They don't look the same, right? They don't look the same. So we ask the next question, is this, okay, the one that we just got, is this the negated version? Okay, is this the negated version of this? Correct. It looks almost like the negated version because you're like, oh yeah, it was positive for the x cube. Now it's negative. It was a plus 4x is now negative 4x. And it was a negative 7 and it is still negative 7. So the negative 7 did not get changed. Did not get changed. So therefore, in this case, we have neither. And this proves one thing, and that is you would never, okay? I do not want to see this next week on the quiz or on test. You should never, ever judge or decide whether a function is even or odd based on the exponents that you see. You actually have to put in the f of negative x in order to see what it is. Yes?
In the first one, the font didn't change either.
Well, because this is exactly the same. And that's why it's called even function.
So all functions, the number without the
It should be negated. Should be the opposite of it.
You have to change all of them, not just change both.
Well, negated, this is the whole function being negated. So all the signs must be flipped. Then you have an odd function. Okay. So, all right, now function operation. I consider this very straightforward. It's more about, do you know how to read? And we did not see this often back in algebra 2. So this is something you should get familiar with. So notation wise, very straightforward. If you see f plus g of x, just know that, hey, this is just adding two functions together, f times g, f times g, f minus g, f of x minus g of x, and then f over g, f of x over g of x. So it's not really that hard. I think the most tempting thing to think is that if you are not familiar with this notation, that you might be thinking about, what is f plus g times x? I think that's really where things could go possibly very wrong, okay?